Welcome to Lesson 17, Function Focus with Miss Barrett. So just to start off this lesson, I wanted to look at the Lesson 18 practice answers. So on Monday, we discussed arithmetic sequences. And just to refresh your memory, an arithmetic sequence is an order of numbers where you're adding or subtracting the same number each time. That's the key for arithmetic. Arithmetic means you're adding or subtracting the same number each time. So we look at this first sequence. It says identify the first term and the common difference. Now the common difference is the number that you're adding or subtracting each time. So the question is, how did I get from 1 to -3 and from -3 to -7? Okay, so remember, how you find that common difference is taking the second number and subtracting the first number. So -3 minus 1 equals -4. Then you take the third number and subtract the second number. So I did -7 minus -3, which becomes -7 plus 3, which is equal to -4. So I found that my common difference was -4. And the first term is really easy because it's just the first number in the sequence. I did the same thing with number 2. I have here the sequence 4, 23, and 42. I know my first number, my a sub 1, equals 4 because it's just the first number in the sequence. There's no math needed there. But in order to find my common difference, I take my second number, which is 23, and subtract my first number, which is 4. So 23 minus 4 is 19. Then I take the third number and subtract the second number. So 42 minus 23 is 19. So my common difference was 19, and my first term was 4. I did again the same thing with number 3. I have -5, 0, and 5. My first term is -5, my a sub 1. Remember that 1 means it's the first term. And I took my second number, which is 0, and subtracted my first number. So 0 minus -5 becomes 0 plus 5 because two negatives make a positive, which equals 5. Then I took my third term and subtracted my second term. 5 minus 0 equals 5. So my common difference is +5. Okay. Guys, this is the first step always. Always. If I give you a sequence and I say, I want you to write an equation, or I want you to find the 10th term, the first step is to always find your first term and your common difference when you're dealing with arithmetic sequences. Part 2 uses these same sequences. So 1, 2, and 3 on part 1 is the same as 1, 2, and 3 in part 2. It's the same sequences. So part 2 says write the explicit formula for these sequences. So we already know what the first term and the common difference are. Now all we have to do is plug that into our explicit formula, and I have the formula here for you. So what we know is a sub 1 and d. So if I have a sub n equals a sub 1 plus d times n minus 1, I'm going to plug in a sub 1 and d because those are the only things I know. So for this first one, it became a sub n equals a sub 1, which is 1, plus d, which was -4, times n minus 1. I only plugged in what I knew. Now, once you plug it in, you can distribute that d. So -4 times n became -4n, and then -4 times -1 became 4, which gave us a sub n equals 1 minus 4n plus 4. Now, once you distribute, you can combine your like terms. So I combined 1 and 4 because they do not have a variable n. So they are like terms. And that gives me -4n plus 5. And I'm done. I cannot simplify anymore. Okay. I also did the same steps for 2 and 3. Plugged in what I knew, distributed, and simplified. Plugged in what I knew, distributed, and simplified. It's the same thing. Now, once you get your explicit formula, in part 3, I said, now using the explicit formula you created in part 2, find the 10th term. The hint here is that Now that you have a formula for the sequence, you can find any term in that sequence. So when I say find the 10th term, I want you to know that it means n is now 10. If I said the 20th term, that means n is now 20. So plug in n wherever you see n. So for the first one, which is the same sequence as part 1 and part 2, I say, I know my formula is, the formula that I got from part 2 was a sub n equals negative 4n plus 5. Now to find the 10th term wherever I see n, so here and here, I plug in n. I plug in 10, sorry. So a sub n becomes a sub 10 to find the 10th term. And then minus 4 times n becomes minus 4 times 10 plus 5. And now you just solve doing your calculations. A sub 10 equals negative 4 times 10, which is negative 40 plus 5. And negative 40 plus 5 is negative 35. So this tells us that the 10th term in this sequence, we only show 3 here, but the 10th term, if I kept going, the 10th term would be negative 35. And I basically just plugged in 10 for the other 2 as well. If you have any questions about this, guys, please, when you bring your quiz review to class with you on Thursday to Zoom class, bring your questions as well. Now, today we're going to talk about geometric sequences. Excuse me. We're going to talk about geometric sequences. So, students will write an explicit formula for arithmetic and geometric sequences. Yesterday we did arithmetic. Monday we did arithmetic. Today we're going to do geometric, and you will have basically a quiz review that you will bring to our Zoom class. Okay. Now, in order to prepare you for geometric sequences, let's review multiplying and dividing fractions. So when you're multiplying fractions, for example, 3/5 times 4/7. When you're multiplying fractions, the rule is to just multiply across. So you would do 3 times 4 and 5 times 7. And 3 times 4 is 12, and 5 times 7 is 35. Okay, so that would be the answer. So whenever you're multiplying fractions, you just multiply across. Now, if I was doing 5 times 8 and 6 times 9, I would still just multiply across because I'm doing multiplication. So that would be 5 times 8 is 40, and 6 times 9 is 54. Okay, so now I get 40 divided by 54. Now, for the sake of this, I know I can simplify this, but for the sake of this, we're just going to keep it there. The whole idea is that when you're multiplying fractions, you're just going to multiply across. Okay, now I want you to pause the video and I want you to multiply these fractions across. Okay, so now we have 12 thirteenths times 2/5. So I'm just going to multiply across, and that's going to give me 24 over 65. Okay. All we're doing is multiplying across for right now. And 7/8 times 4/5 is going to be 28/40. And again, I know I can simplify, but just for the sake of this, I want to show you how just to multiply fractions. Now, dividing fractions. The rule says to flip the fraction and multiply. So here I have 3/5 divided by, let me make this a little thicker, 3/5 divided by 4/7. So I'm going to flip this. I'm going to flip the denominator. So flip the fraction at the bottom and multiply. So if I have 4/7, I'm going to flip it and make it 7/4, and I'm going to multiply. Now we know when we're multiplying, we just multiply across. So really all I did was flip the denominator and multiply. So now 3 times 7 is 21, and 5 times 4 is 20. Another example. if I have 5/6 divided by 8/9, I'm going to take the denominator, I'm going to flip it. And then I'm going to multiply by the flip. So 5/6 is now being multiplied by 9/8. See how I flipped it? So it was 8/9 becomes 9/8. So now, after I flipped it and then I multiplied, now I'm going to multiply across. So 5 times 9 is 45. 6 times 8 is 48. So it's now 45/48. Okay. Now I want you guys to try it. So for dividing, you're going to flip the denominator and then multiply. Okay. So my denominator is 2/3. So I'm going to flip that and multiply. So I'm going to multiply by 3/2. And I'm going to just multiply across. So now it's going to be 12 times 3, which is 36, divided by 13 times 2, which is 26. And again, I know I could simplify this fraction, but just for the sake of this, I just wanted to show you how to divide by fractions. Now, on letter B, I have 7/8 divided by 4/5. I'm going to flip this and divide. And multiply. So 4/5 turns into 5/4, and then I'm going to multiply across. Okay, you're only flipping the bottom fraction, by the way. Just a reminder. So now 7 times 5 is 35, and 8 times 4 is 32. Okay, so you will need to remember how to divide by fractions when you're doing geometric sequences. Okay, now geometric sequences. So a geometric sequence, a sequence is geometric if I give you a sequence that looks like this: a sub 1, which is the first term, a sub 2, a sub 3, and so on and so forth. So I find it could be a sub n could be a million, n could be 10. Okay, so that means it would be a sequence with 10 numbers or a sequence with a million numbers, whatever n is. Okay, if I give you that sequence like this, the sequence is geometric if the ratio, and the word ratio is important here, of consecutive, one after the other, terms are the same. And I'm going to tell you what that means in a moment. So a geometric sequence, is geometric if the ratio, pay attention to that word ratio, of consecutive terms are the same. So what this really means is if we're multiplying by the same number each time. Okay, so if I go from a sub 1 to a sub 2, I multiply by a number. If I go from a sub 2 to a sub 3, I have to multiply by the same number. The difference between arithmetic and geometric is arithmetic is adding or subtracting, and geometric is multiplying. That's important. Okay, so how do you find the number that is the ratio? We denote by R. Okay, so we call R the common ratio. So remember, with arithmetic we had D. Well, with geometric we have R. And we find R by taking a sub 2, or the second term, and dividing it by the first term. And then taking the third term and dividing it by the second term. Okay? And then we take any term, a sub n, and divide it by the previous term, a sub n minus 1. That's how we find r. Okay? And I'm going to show you what that means in a moment. So now, here is the geometric explicit formula and the geometric recursive formula. So we're going to be paying more attention to the explicit formula. This is the most important formula. Okay? I just wanted to show you the recursive formula, but the explicit formula is what we're going to see on your quiz. So what does n mean? N means the term you want. Term you want. Just like arithmetic. All these mean the same thing except for r. A sub n is the term place, or where the number the term is the term place, or I would say the number that the term is. Okay. A sub n minus 1 is the previous term. Again, you really don't need that for this one. That's more for the recursive. And r is the common ratio. Is the number that you're multiplying by each time. Okay, the number you're multiplying by each time. So, for example, for each sequence below, write the explicit formula for the nth term and find a sub 6. Okay, and find a sub 6. So, here's our explicit formula. Our explicit formula says a sub n equals a sub 1, or the first term, okay, a sub 1 times the common ratio raised to the power of n minus 1. Okay. So we have to identify two important things. The first term, just like arithmetic, and the number that you're multiplying by each time. So the common ratio, which is r. So let's look at our sequence. We have 5, negative 15, and 45. So we're going to take, just like we did up here, we're going to take the second one, which is negative 15, and we're going to divide it by 5. So you take the second number, which is negative 15, and divide it by the first number. So we're going to do a sub 2 divided by a sub 1, which is going to be negative 15 divided by 5, which is negative 3. Okay, and then we're going to take the third term and divide it by the second term. So we're going to take a sub 3 and divide it by a sub 2. A sub 3 is 45 divided by a sub 2, or the second term, which is negative 15, which equals negative 3. So it's clear that the common ratio is negative 3, which means that we're multiplying times negative 3 each time to get to the next number. So we're multiplying by negative 3, multiplying by negative 3. All right, so our common ratio is negative 3. Our first number, a sub 1, is 5. That's easy because all you have to do is look at the first number. Okay. Now I'm going to plug in what I know. The only thing I know, the things that I know here are, the first term is a sub 1 is 5, and the common ratio is negative 3. So where I see a sub 1 and r, I'm going to plug in 5 and negative 3. So a sub n equals a sub 1 is 5 times r, which is negative 3. So times negative 3 raised to the power of n minus 1. I don't know n. So that n minus 1 stays the same. The only thing I plugged in is what's green, a sub 1 and r. Okay. Now I do not distribute. Do not distribute. This is it. This is it. So I have a sub n equals 5 times negative 3 raised to the power of n minus 1. That's all I can do. So this is a little bit easier. So it says now I want to still find the sixth term. So a sub 6 means that n is equal to 6. Okay. A sub n means n is equal to 6. The a sub 6, means n is equal to 6. It's the sixth term. So the sixth term is what I want to find. Okay. So if you see here, see how it says a sub n, but now it's a sub 6. So wherever I see n, now I'm going to plug in 6. So plugging in what you know is the easiest part here. Okay. Now that we've figured out our formula, we then need to find the sixth term. So wherever I see n, I'm going to plug in 6. So it becomes a sub 6 equals 5 times -3 raised to the 6 minus 1 power. Okay, now I'm going to simplify that. So now a sub 6, didn't mean to write it in green. A sub 6 equals 5 times -3, and then 6 minus 1 is 5. Okay, so I plugged in what I know. Then it says I want to find the sixth term. A sub 6 means the sixth term in the sequence. That means n is 6. It's the term I'm looking for. Okay, so now I plugged in 6 for n, and I simplified it. And now I can do my math. So it's 5 times -3 to the 5th power. Remember, please excuse my dear Aunt Sally. So the first thing I have to do is my exponent. So I'm going to take my calculator. I'm going to do parentheses. Whenever you have a negative number, -3 raised to the 5th power is -243. So now this becomes a sub 6 equals 5 times -243. That was -3 to the 5th power. And when I do 5 times -243, I get -1,215. So the question is, what is the sixth term? The sixth term of this sequence is -1,215. That means that if I did 5 times -3, I get -15. -15 times -3, I get 45. 45 times -3 is -135. That's the fourth term. -135 times -3 is 405. That's the fifth term. 405 times -3 is -1,215. That is the sixth term. So each time I just multiply by 3. But this formula that we got tells us what any term is in this sequence. But I just asked you for the sixth term. Okay, now let's do it with this one. Number 2. This is where we're going to have to use our fractions. We have 1/8, 1/4, 1/2, and 1. So the first term is easy. Okay, I'm going to put it in green. The first term is 1/8. We can see that because it's the first number in the sequence. No math needed. Now the common ratio, however, is going to be harder to find. I'm going to take the second term and divide it by the first term. Okay, so the common ratio, so R equals the second term, so a sub 1 is 1/8, a sub 2 and a sub 3 is 1/4 and 1/2. So I'm going to take the second term, 1/4, and I'm going to divide it by the first term, 1/8, which means I'm going to flip this, flip 1/8, it becomes 8/1, and I'm going to multiply across. That's going to equal 8/4, which is 2. Then I'm going to take my a sub 3, which is 1/2, and I'm going to divide it by a sub 2, which is 1/4, which means I'm going to flip this bottom number and make it 4/1, sorry. 4/1, which is going to give me 4 over 2, which is 2. Okay? Right? So that means that my common ratio, as you can see, is 2. All right? Whenever you have fractions, you're going to have to remember, if you're dividing fractions, you're going to multiply by the flip. Now I have my first term and I have my common difference. I'm sorry, common ratio. So now I'm going to take my explicit formula. A sub n equals a sub 1 times the common ratio raised to the power of n minus 1. I'm going to use these same steps that was in this graphic organizer. I'm going to plug in what I know. So I'm going to plug in a sub 1 and r. And why I don't have this graphic organizer over here, guys, because I want you to kind of get in the habit of knowing what steps to do. So you might not always have this graphic organizer. So now I have a sub n equals a sub 1 plus r raised to the n minus 1 power. I will always give you the explicit formula. You have to know what to plug in. So now I have a sub n equals, we know a sub 1 is 1/8 times r, which is 2. Okay, which means that we multiply times 2 each time. Okay, so then we're going to raise that 2 to the n minus 1 power. So all we need to do is plug in what we know. We plugged in what we know. There's nothing else we can do here. Now we need to find the 6th term. So now I want to find a sub 6. A sub 6 equals what? That means n equals 6. Okay, so I need to plug in 6 wherever I see n. All right. So now it's going to be a sub 6 equals 1/8 times 2 to the 6. Let me do it in green. 6 minus 1 power. Okay, the 6 minus 1 power. All I did was wherever I saw n was here. N was here. I plugged in 6 because I'm looking for the a sub 6 or n equals 6. Now, 6 minus 1 is 5. So a sub 6 equals 1/8 times 2 to the 5th power. All I did was did 6 minus 1. Okay. Therefore, I'm going to go on my calculator. I want to simplify this. I have to do my my exponent first. 2 raised to the 5th power is 32. This is going to give me a sub 6 equals 1/8 times 32. Okay. Do 1/8 times 32. You can use your calculator. Parentheses, always put fractions in parentheses. 1/8 times 32 equals 4. So, ladies and gentlemen, what this says is if I'm multiplying 2 each time, when I get to the 6th number, I'm going to have 4. The answer will be 4. Okay. All right. Using these 2 examples, I want you to try to do numbers 3 and 4. And then come back so we can go over it together. Okay. Number 3. The first term is 512. Okay. How do I find my common ratio, or what I'm multiplying by each time? Okay. I'm going to take my second term, a sub 2, and I'm going to divide it by a sub 1. So 200, so a sub 2 divided by a sub 1 is 256 divided by 512. What does that equal? It equals 0.5 or 1/2. It's the same. So then I have to do a sub 3 divided by a sub 2, which is 128 divided by 256. And you're going to get the same answer. okay, you're going to get the same answer. All right, I did a sub 2 divided by a sub 1. I got 0.5. A sub 3 divided by a sub 2. I got the same answer. So I'm going to put 0.5 here. So these are the two things I need to plug in now into my equation. So my explicit formula for geometric sequence is a sub n equals a sub 1, the first term, times the common ratio raised to the n minus 1 power. Let's plug in what we know. A sub n equals a sub 1, which we said is 512, the first term, times the common ratio, which is 0.50, raised to the n minus 1 power. The only thing I know is the first term in the common ratio. That's all I plugged in. Now, I'm done. I can't simplify anything else. So now I can use this formula to then go and find the sixth term. So a sub 6 equals what? Well, n equals 6 here. See how it's a sub n, but then we have a sub 6, so the 6 replaced the n. So now we know that wherever we see n, we have to put a 6. So it's going to be a sub 6 equals 512 times 0.50 raised to the 6 minus 1 power. So remember, we're just plugging in 6 wherever we see n. Okay, now I can simplify this. Here, a sub 6 equals 512 times 0.50, and 6 minus 1 is 5. Okay, now if this is 7 minus 1, it would be 6. If it was 12 minus 1, it would be 11. All I'm doing is saying 6 minus 1, and that gives us 5. Now I can continue doing my math. A sub 6 equals, to solve this, I have to first do my exponent. So I'm going to do 0.5 raised to the 5th power. And that gives me 0.03125. Okay? That gives me 0.03125. So that's 512 times 0.03125. Decimals are okay. Do not be scared of decimals. Okay? You can make them fractions, but I feel like that just makes it a little bit harder. Okay? So a sub 6 equals 512 times 0.03125. Now I'm going to multiply them together. That gives me 16. And see how it came out a pretty number. So what this tells us is that the sixth term in this sequence is 16. Okay. Number 4. My first number in my sequence is 3. That's easy. A sub 1 is 3. Okay, now I need to figure out, now I know this is geometric, so now I need to figure out, okay, whether what number I'm multiplying by each time. So I'm going to take my second term, this is a sub 1, a sub 2, a sub 3. I'm going to take my second term, okay, 6, and I'm going to divide it by 3, and that gives me 2. And then I'm going to take my third term, 12, and divide it by 6, and that gives me 2. Okay, so therefore my common ratio is 2. So now I take my formula, a sub n equals a sub 1 times r raised to the n minus 1 power. Okay, I'm going to plug in what I know. So a sub n equals, a sub 1 is 3 times r, which is 2, to the n minus 1 power. Everything in green is what I know. I don't know anything else, so that I can't do anything else. That's it. I'm done. So now I'm going to take this formula and I'm going to find the sixth term, a sub 6. That means n equals 6. So wherever I see n, which is right here, and right here, I'm going to plug in 6. A sub 6 equals 3 times 2 raised to the 6 minus minus 1 power, which is going to give me a sub 6 equals 3 times 2, 6 minus 1 is 5. Now 2 to the 5th power is 32. I think we got that for another one. So 2 to the 5th power is 32. So a sub 6 equals 3 times 32. Okay, therefore a sub 6 equals 3 times 32 is 96. So what this means is, if I keep on multiplying times 2 here, when I get to the 5th number, I'm going to multiply that times 2, and it's going to give me the 6th number, which is 96. The 6th number in the sequence is 96. Okay, so now we've talked about arithmetic, which is when you add or subtract the same number in a sequence, and geometric, when you multiply by the same number in a sequence. So for your quiz review, which you will bring to your Zoom class, for your quiz review, the first part says to determine whether or not each sequence is arithmetic or geometric. That means you're going to have to use those rules to find R or D. So you're either going to have to do a sub 2 minus a sub 1 and a sub 3 minus a sub 2, or you're going to have to do a sub 2 divided by a sub 1 and then a sub 3 divided by a sub 2. If you get the same number, then you'll see that it is arithmetic or geometric, or neither. Okay? Again, we will go over this. Part 2 says, identify the sequence as arithmetic or geometric. Identify a sub 1 and D if it's arithmetic, and then a sub 1 and R if it's geometric. Then use what you know to create an explicit formula for each. Okay. Then part 3 says, find the 20th term. So use the explicit formula you created in part 2 to find the 20th term. So you're just going to take your formula and put in 20 wherever you see N. Again, we will go over this. So bring this to the Zoom class that we will be having tomorrow. Hope to see you then, ladies and gentlemen. Have a wonderful day.